All right, problem 68. Find the values of p and q that make the piecewise function differentiable for all values of x. F of x equals px minus 1 when x is greater than 2, and negative qx squared plus 2 when x is less than or equal to 2. So if it is differentiable, it means two things are happening. It means the function is continuous. So to force this function to be continuous, we need to set px minus 1 equal to negative qx squared plus 2 when x equals 2. So we get 2p minus 1 equals 2 squared is 4, so negative 4q plus 2. Let's leave that for now. Let's go to our second equation. Our second equation comes from the derivatives needing to be continuous. That's what it means for a function to be differentiable. The function is continuous, and the derivative is continuous as well. So what's the derivative of px minus 1? It is just p equal the derivative of negative qx squared plus 2. Well, power rule says take the 2 and multiply it in front. So negative 2q x, subtract 1 from the power, and the 2 goes away. So plug in 2 to that function, so p equals 2 times negative 2 is negative 4q. So let's solve this now. Quickest way to solve it is to see a negative 4q and a negative 4q, which means we will replace that with a p. So 2p minus 1 equals p plus 2. Let's subtract p from both sides, so we now have a p on the left. Let's add 1 to both sides, so p equals 3. If p equals 3, what is q? Well, let's take that 3 and put it back here. So 3 equals negative 4q, which means q equals negative 3 over 4. Finished. Not very much work necessary to do that problem. I totally did it wrong in the answer key though, so check yourself, make sure it's correct, unless I've already updated it, in which case, hooray for me being proactive.